Good morning, dear students. Before I start, once again, thanks a lot for your responses. I'm getting nice responses via mail, but once again, my request all these responses better put in comment box so even other students will able to use it. Anyway, this is the next chapter. We are going to have expansions, and again, let me remind you, we are not solving here plenty of problems. This lecture series is just to clear the concepts. Now in these expansions, mainly we are going to see Maclaurin's expansion. You will be given a function and we need to find expansion of that function. Now to find the expansion, first thing we are going to use three methods. First one is directly using Maclaurin's expansion. That will be our first method. Then we are going to see using standard expansions, and then we will see the method of differentiation and integration. These three methods basically we are going to discuss maybe in 2 or 3 lectures. Now again, important thing is all these methods are easy to understand. I will explain you this quickly. The important part we will see is whenever you look at the function, you should able to find out for which function which method you can use, and that is a very important thing, because you cannot do you tried this method, you cannot do now go for this method, you tried, you cannot do now you go for this method, just waste of time. So at the end I will tell you this important point. If you are appearing for exam and you are seeing some unseen problem, unknown function, you have to find its expansion. So first give at least few seconds, 15 to 20 seconds, to find out which method can be used. So that I will tell you at the end after explaining these methods. So first in this video we will see the Maclaurin's expansion. Now this Maclaurin's expansion for a given function f, it is given by f of x equal to f of 0 plus x into f dash 0 plus x square upon 2 factorial f double dash 0, etc. No need to mug up. See the pattern what I always tell you. Look at the terms. What kind of terms we have? You can see the terms f0, f dash 0, f double dash 0, f triple dash 0. Then when it is first derivative, it is x is to 1 upon 1 factorial, second derivative x square upon 2 factorial, third derivative x cube upon 3 factorial, etc. So when you want to find expansion of any function using Maclaurin series, it's a simple thing. Actually find out f0, f dash 0, f double dash 0 and substitute. So let's have some example. I will give you, say fx is log of 1 plus x. Okay, one more thing I haven't written here. Whatever is the Maclaurin's expansion, do you think it's for any function? No. To have this Maclaurin's expansion for a function, first thing, the function should be continuous with continuous derivatives. Then only we can get this Maclaurin's expansion. So anyway, say this is a given function and we want to find Maclaurin's expansion. Look at this and we'll find one by one all the terms and we will substitute. The first method using Maclaurin's expansion is that simple. See, we need f0, f dash 0, f double dash 0, etc. So we'll start with, we have fx is log of 1 plus x. That gives us f of 0 is log of 1 plus 0. That is log of 1, and all of you know log of 1 is 0. Then first derivative, log of 1 plus x, derivative is 1 upon 1 plus x. So again I have f dash at 0 is 1. Put x equal to 0. Second derivative, that will be minus 1 upon 1 plus x whole square. So again second derivative add 0, that is going to be minus 1. Let's go for one more derivative, say the third derivative, and you can say it 1 plus x raised to minus 2. So minus 1 into minus 2, that is 2 upon 1 plus x cube, and that gives us the triple derivative at 0. It is going to be 2 upon 2 cube, which is 1 by 4. I'm so sorry, we are putting here 0, extremely sorry. It will be 2. We are putting x equal to 0, etc. And all these values now we are going to put in this Maclaurin series. So if you put it here, what you are going to get, our given function is log of 1 plus x. So fx equal to, see, so I will have log of 1 plus x equal to f of 0. F of 0 is 0 plus x into f dash 0, that is x into 1, plus x square upon 2 factorial into f double dash 0, that is minus 1. Next term is plus x cube upon 3 factorial into the third derivative, which we found to be 2. And then open it, expand it, what we are going to get? This will be x minus x square upon 2, 2 factorial is 2, plus this is 2 upon 3 factorial, 2 is cancelled. So x cube upon 3, you can cross check. Next term you are going to get x is to 4 upon 4, etc. And this is the expansion of log of 1 plus x. And like this you can find expansions of various functions, that is using Maclaurin's expansion. Now using this Maclaurin's expansion we can find various expansions, as I said. So there are some standard functions whose expansion you should know. By using them only we are going to have our next method, that is using the standard expansions. Now what are those expansions? Which expansions you are supposed to know? First of all, e raised to x. E raised to x, it is 1 plus x square upon 2 factorial plus x cube upon 3 factorial, etc. Now what are expansions? I'll write here. As usual what I tell you is, please don't mug up anything. See the pattern. See the pattern is very easy. X is to 0 upon 0 factorial. X is to 0 is 1, 0 factorial is 1. X is to 1 upon 1 factorial. X is to 2 upon 2 factorial. X is to 3 upon 3 factorial, etc. From this you can always remember expansion of cos x and sin x. Cos x, all the similar terms, only even powers with alternate plus minus. So I will have 1 minus x square upon 2 factorial plus x is to 4 upon 4 factorial minus x is to 6 upon 6 factorial, etc. And your sin x will be all odd powers again with alternate plus minus. So it is x minus x cube by 3 factorial plus x is to 5 by 5 factorial, etc. Now any of the standard expansions you can always find out using Maclaurin series. Whatever we had done, log of 1 plus x, exactly same way you can find all these expansions. We have tan x, that is x plus x cube by 3 plus 2x raised to 5 upon 15, etc. Next we have sine hyperbolic x. Again I can tell you, whatever you have for sine x, similar for sine hyperbolic, only thing in sine we have alternate plus minus. For hyperbolic we are going to have all plus. Same way for cos hyperbolic x. Cos hyperbolic x, again whatever we have for cos, it's same, only difference all are again plus. So this is my point. Every time I am telling you, don't just mug up It's very difficult if you mug up. You can remember in this way. Same way you have for tan hyperbolic x, which is again what all tan x we have. In tan x we have all plus. For hyperbolic it's same but alternate plus minus. So this is tan x is x plus x cube by 3. So I will have x minus x cube by 3 plus 2x raised to 5 by 15 minus etc. Then after this, just now we have proved log of 1 plus x. Log of 1 plus x, what we proved just now is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 etc. Now exactly same way, log of 1 minus x, again I will say the same terms, only difference here all are minus. That is log 1 plus x, it's alternate plus minus. For log 1 minus x, all are minus. So again I'm telling you this way you can remember all the expansions, because you must know them and you can't just simply mug up them. Next expansion you can have is 1 upon 1 plus x. Again 1 upon 1 plus x, 1 upon 1 minus x. You can remember in similar way. Here the terms are 1 minus x plus x square minus x cube etc. See again for 1 plus x alternate plus minus, 1 upon 1 minus x same terms but we have all are plus. Lastly I will give you 1 plus x raised to p. P is any rational number, not necessarily integer. When it is integer, you know there is a binomial expansion. When it is integer, again it's similar to binomial. I can have it 1 plus p into x plus p into p minus 1 upon 2 factorial x square plus p into p minus 1 into p minus 2 upon 3 factorial x cube etc. So you can see again this p, actually p is pc1, this is pc2, this is pc3, just to remember in that way, because here p being a fraction we cannot define pc1, pc2, these are undefined term. But just to remember this expansion I can tell you what is the formula of pc1, that is p. PC2 is going to be p into p minus 1 upon 2 factorial and powers of x are increasing. So this is expansion of 1 plus x raised to p. Now these are the standard expansions you are supposed to know. So this was the first method, as I said, directly using Maclaurin's expansion, and using this we can find expansion of all these standard functions. And in our next video we will see how to use this standard expansion. That's our second method. By using standard expansions, how to find expansion of any given function. So let's see it in next video. So goodbye till then. Have a nice day. Bye.